All right, so I hope everyone had a great Super Bowl Sunday weekend. It was a great game yesterday. I was very, very tense for the last quarter. It's not like last year's Super Bowl where they just got completely blown out. So I was pretty pleased with the outcome yesterday. Hopefully, everyone enjoyed the good game, and we're back today to learn about HTTP. Again, like I mentioned, HTTP is not one of those things that's absolutely crucial for your first job. Um, but it is one of those things that will help you in interviews for your first job. Now, this is largely conceptual. Like today, this morning's lecture is very, very largely conceptual because, yeah, it's just largely conceptual. It's basically how the web works. So HTTP is the web's protocol. There's a certain protocol of like when there's protocols for everything on the web, and the way that we talk with the internet, with websites and things of that nature is through HTTP. Now, HTTP stands for Hypertext Transfer Protocol, which has origins as early as the 1930s. If you've ever gone to like an old website and it looked something like this is using the HTTP protocol to get and receive data. This large block of text, you can kind of read at your own leisure. There is all of these slides are on your curriculum for today. But basically, at the very beginning, when HTTP was first created, it was just a protocol to talk about hypertext. The modern equivalent of hypertext today is HTML, and like the protocol has kind of evolved over time. At first, it was just to kind of transfer like papers back and forth with like between different departments at universities and things like that. And it was just at first it was mostly just used for doing hypertext. Hypertext today, again, the same equivalent is going to be HTML. And as the HTTP protocol evolved, you can actually use almost any type of, you can transfer any type of file. You can do images, you can do JavaScript files, HTML files, JSON responses, which we'll talk about in just a second. You can even do like movies over HTTP. So it's just the protocol that we use to talk back and forth. And this is how it looks. So when you are having a conversation with different people, when you are having conversations with different people, there are two different parties at play. There's a client, and then there's a server. The client is you. Like you are having a conversation. You are one half of the equation. The person that you're talking to is the server. So again, you are the client. So your computer, the one that you're dealing with, is the client, and the server is the other party in the room, like the other person that you're trying to make a request to. So you send an HTTP request over to the server, and they send an HTTP response in return. The requests and responses are both plain text. They're easily read. They're consistent every single time because it's a protocol. It's something that's going to be the same every single day. This is how it looks. I'm on the wrong screen. So a request is here on the left, and a response is here on the right. We're going to break down literally every single line so that you have a general idea of what's going on behind the scenes. So first things first is this top line of the request. This is called the request line, and it's broken up into three categories, and it's the same thing every single time, 100% of the time. The first word is the method, like what kind of request am I sending? The second thing, the URI, is like basically where am I actually going to, and then the protocol version. As of right now, it's always going to be HTTP 1.1. The protocol is always going to be HTTP 1.1. Now, this is pretty simple because it remains the same. Like, what's the version you're sending over? This is kind of obvious. It's kind of like the URL. It looks a little bit like the URL, but it's a little bit different. But the thing that everyone has not seen before is most likely this method right here. It's called get. Let's break down all these different methods. So when you make a request to somebody, there is some nonverbal communication going on, meaning that if I walk up to Danny and I got a big smile on my face, Danny, when he receives that, like my interaction with him, he thinks I'm a friendly person because I have a big smile on my face. If my face is very cross, if my hands are clenched, and I'm coming at a high rate of speed or something like that, Danny knows, okay, I have some sort of danger coming at me. This guy seems to be very aggressive. There are nonverbal communications like when I'm sending a request and response. There's not any of those kind of like nonverbal cues inside of HTTP requests. You have to be very, very explicit. It's not as smart as a human being, where you can see like, oh, Raymond's running at me and he's got like his shoulders lowered and his hands are cocked and stuff like that. I know based on that I'm inferring that he's going to come at me with some sort of attack. Computers are not that smart. So computers, you need to explicitly tell what type of request is coming through. And that's these methods right here. There are, I don't know, like 15 different methods, if not more. But these are the most common ones. The most common ones you need to be in charge of are get, post, delete, and put. I didn't put in here. I'll change that right after this. So get is pretty simple. I'm making a get request. I want to get information from the server. So I'm basically, whenever you make a request to google.com or Amazon or eBay and you just type it and you press enter, that's a get request. It's basically saying, hey, Google, I'm making a request to you. Give me the information that I'm looking for. A post request is one where I'm sending information, something new. So whenever I fill out a form and I press submit, that's a post request. It's saying I'm updating something on your website. Like I want you to write this into your database. I'm sending you something. Delete is pretty simple. It's basically saying like delete my account. I'm sending a request for you to delete something. And then put is something already exists inside of your database. I want you to update it. So those are the big four. Get, I'm just going to get all the information. Post, I'm sending something new. Put, I'm updating something. And then delete, I'm going to delete something. So that talks about this very first thing, which is this method right here. That's the first thing. Like it's explicitly saying, what are you trying to do with this request of yours? The second thing is a URI. URI stands for Uniform Resource Identifier. And this is a little bit different from a URL, which is what you're used to. So URI stands for Uniform Resource Identifier. It's this / whatever at the end of the .com or the .org or whatever. The URN is your host. The host is being like google.com plus the URI. So it's like google.com/search.html or something like that. That would be, those two things put together are URN. When you throw www in the front, in case you haven't figured it out, dub is short for W because W is 3 syllables and dub is just 1, so it's www. So when you have HTTP www and then the host and then the URI, that whole thing, those 3 parts actually make up a URL. In our case, we're just talking about the URI inside of the request. So there are different types of HTTP requests. The first one we saw was this thing right here. I'm making a GET request to this particular URI with this particular version. I'm not sending any information. I'm just saying like, I go to google.com to be like get, I think it's just google.com and then HTTP 1.1. And then google.com gives me a response of some sort. Sometimes when you make a request, you're going to post something. You're going to fill out something. So we break this down in terms of the first line is just the request line. I'm making a post request to /search with this particular HTTP version, the protocol version. Inside of there, I'm sending in some headers. So again, I'm explicitly telling you what I'm doing. I'm telling you I'm making a post request to /search with this particular HTTP version. Inside of there, I have some headers. Where the host is where you're making the request to, like google.com. The user agent is Google Chrome 5234. The content type is application. This is example of headers. So again, host is the google.com, amazon.com, ebay.com, codeplatoon.org. The user agent is basically saying this is the type of machine that's sending over a request. Why do you think sending, like this is the type of device that's sending over a request? Why do you think that's important? Like, why is it important for us to send over like what type of device is making a request?
You need to know who the client is.
Something about how the response comes back. Leanna, you had something?
You need to know who the client is.
Yep, you need to know like what type of thing is making a request. So if you've ever gone to a website and you've gone to like, let's go to FBI.gov. Based on, let's put it this way. Have you ever gone on your phone open up a web page, and then everything is written in web format, meaning that you have to like scroll around and you have to make it bigger and you have to make it smaller in order to see anything. That's called a non-responsive website. And as we write code and we start to do front-end stuff later this week, we want all of our stuff to be responsive. So this is particularly important when I'm figuring out what type of user agent, what's my client sending over. If I'm making a request from a mobile phone, don't send me a response that's in desktop format because it's too big for my phone. And if I'm on a desktop, I don't want to see something written for a phone because it's not quite large enough. You can see if a website is responsive by just going to any website and just crushing it down a little bit, little by little. You can kind of see this view right here. The smallest view is most likely for a phone. If I make it a little bit larger, it jumps into like tablet format right there. And then if you go even larger than that, it goes into full desktop mode. And if you right click, hit inspect, you can kind of see what's happening here. It says it's responsive at like 507 by 594. You also have the option, because so many people develop on Google Chrome, to see what does this website look like for a Galaxy S5. It looks like that. Maybe for an iPhone X, what does it look like? It looks a little something like this. You can see what it's like for an iPad. This is all built into Google Chrome. So this is the idea, and the importance behind this is basically saying, if I'm making a request, I need to know what is making the request. Is it going to be a mobile device? Is it going to be a desktop device? Is it a tablet? So I can alter based on what you're sending over. I can create a specific response for you that comes back to you. When you make your websites, most likely you'll have a desktop version, mobile version, and tablet version. Or you can make what's called responsive, which will just automatically squeeze and get larger based on what device is being making the request. And again, I can just do that by pulling it smaller like this. This is just written in responsive, so it adjusts to the size of the screen. The other important thing when it comes to user agent right here is it keeps track of analytics for you. So if I have, so we used to, for the old payday lending company that I used to work for, well, subprime lending, we took down, when you send a request, we get all of this user agent stuff for free because every single request has it. So we can see, okay, 40% of our users are coming from Google Chrome, 25% of them are coming from Firefox, and then 1% is coming from Internet Explorer. On top of that, I have version numbers. So whenever we get people saying, I can't see anything on your website, and we check it, it says Internet Explorer 1.0 or 5.0 or something like that, we know that we're dealing with someone who's only 1% of the population of our website. Do we care? Not really, because they're part of the very, very small subset. If someone was saying Google Chrome 5234, I think we're on 60 something now. It's if Google Chrome 60 point something is broken, and that's 40% of our users, you can guarantee that's where we're going to spend our resources. But for that one person who's Internet Explorer 5.0, I'm probably not going to take their request as seriously because they're only 1% of the population. And that's unfortunate, but that's just where we have to spend our resources. So again, this request starts off with a request line. I have my method, the URI, and the HTTP protocol number. Inside of the headers, it's basically saying this is the type of content that's coming through. I want to go to google.com. This is who's sending, whatever type of machine is sending over the request. And then this is what's inside of it. So if you've ever seen a ship with a manifesto or something like that, this is the contents of this ship. Or it's if you've ever gone to the post office, you ship something to somebody else, they always say, do you have batteries inside of here? So you have to declare what's inside of it. Oh no, it's just papers or something like that. And then inside of here, there's what's called a query string. A query string is basically, this is just an example of a query string. It's an optional thing that goes inside of the body that goes along with your search request. So you have two options. One of them is if you're looking for new red Jordans, you can make a post request and search for it, or you can make a GET request with it as well. And to show you that, I kind of loaded up Walmart.com. Now, if you go to Walmart.com, you can kind of see this giant thing up here. This is a URL. It has the HTTP protocol. It has the protocol, which is HTTPS, the www, and then this is the host name, walmart.com, and then there's no URI right now. One thing to keep in mind, I just wanted everyone to know that what's the S stand for at the end of HTTP? Secure. So if you're doing anything with banking, anything that requires any sort of personal information, you always want to make sure this S is on there and this little lock button is there, just so that you know that the information you send back and forth is encrypted. Because if you don't, I will show you with this particular thing. So you can see right away that this particular URL doesn't have the HTTPS in the front, correct? Watch what happens. Inspect the element over here. It's under network. Yeah, network. When I hit login right here, and again, I'm on the left side, I have this under iPad. If I press login right here, it goes all the way through. These are all the different HTTP requests that are going back and forth. So you can see there's more than one thing happening, right? All of this stuff is happening on the back end. But the main thing is this login. If you take a look at what I'm sending over, request headers, form data, all of a sudden my login is no longer encrypted. So I have, this is my name, john@codeplatoon.org, and then it just shows my password in plain text. Okay, this is a bad thing. You do not want this to happen to your website. You want everything to be secure. The reason this is showing up just as plain text under form data like this is because it's not an HTTPS. It's not secure. So that's kind of scary. Imagine if they could do this with your banking information, right? It's just like john@codeplatoon.org, and then my password is whatever my password is. But just to make this is just kind of, I mean, this is not a big deal to not make HTTPS because it's just a booking site for Level Office and it's WordPress site, and somebody should update this. But I've been making fun of them for the past year, so I'm going to continue on with this.
What if you use your password that you use for everything on that?
Exactly, that's the issue, right? This particular thing I can see on my computer is unencrypted. Everyone else on this network can also see my requests. And if they see like a username and a password that's in plain text, they can grab that username and that password and try it on everything. Your Amazon account, your Chase.com account, your Bank of America, your Merrill Lynch, all of your very, very sensitive websites, I can just grab it and try it. And everyone can do this. We're on a public, you can safely assume that everyone can read everything that's going on, unless you're connected to the Code Platoon network, which no one can see.
So how are people on the network able to see your password?
So they are able, everyone who's able to, so there's a giant log. I'm not a hacker, so I don't know, but I know it's technically possible to watch all the network traffic going through on a particular network. So Level Office or like a Starbucks or something, someone can sit there and just kind of wait and just have like I think they're called packet sniffers. They just literally just listen for any sort of, and record all the different transactions that are going on, all the HTTP requests going back and forth. And they're looking for things like this, where it's like a login email address with a password of anything that looks remotely like nothing like this, but looks like an actual like password. And then once they grab this, then they can use it as they wish. We're going to have somebody coming in to talk about application security because I'm not an expert on it. All I know is HTTPS, don't save your passwords in plain text. It's very important not to do that. Yes, HTTPS for everything, otherwise something like this happens. So just be careful. Going back to like Walmart.com, we know Walmart is very secure because of all the hacks recently and things like that. So I'm going to submit a particular thing right here. I'm going to look up red Jordans. Now, when I hit enter here, this is a form. This one little search bar up here, this is just a form. When I hit this, I'm sending a request over, and let's see what kind of request I'm sending. Inspect element over here. I'm going to go to network. All right, let's clear everything. Okay. I'm going to just hit go. And right there, this tiny little thing, you can kind of see this is the this is that HTTP request that's being sent over. Now, Google Chrome makes it nicer for you so you can read it a little bit easier. But hopefully some of this is starting to make sense. So we have a request URL. We have a request method called get. What does get do? What does get do?
Retrieve.
Yeah, it just goes out and retrieves something from the server and brings it back to you. Let's see. Let's take a look at other things. This is all about the response, which we haven't gotten to yet. Let's take a look at the request headers. We're sending it to Walmart.com. We're sending it to the get. We're making a get request. This is the path we're sending it to. We're willing to accept certain things. There's a cookie being set. User agent is Mozilla 5.0. I'm on an iPad, evidently, because my thing is shrunk down to this particular size. And this is the query string that's being sent over, Red Jordans. Let's jump back over here.
Why is it saying Mozilla here on Chrome, right?
Yes, I have no idea what that is.
Okay.
Yeah, I will look it up.
No, it's not that big a deal.
I don't know. Short answer is I'm not sure. All right, so when you make a request, you can either send stuff as a post, or more likely, they're going to make a GET request. And you can, the way that we break this down is when we look at this particular thing here, is when we go to /search, anything after a question mark is called a query string. So the query string basically starts anything after the question mark. And there are a few things. If I do query equals air, this %20 is UTF-8 encoding for space. Air Jordans, and the color is going to be red. Like they're able to, you're basically able to, if you take a look right here, so I have walmart.com/?. This is where the query starts. So the query is going to be equal to red space Jordans. That's what you looked up. If I were to look up, let's say I wanted to look up, maybe I'll do black Jordans. All right, so this after the search becomes a query string. So the query is going to be black space Jordans, and cat ID is equal to 0. This cat ID, I'm not sure what it is. They shove it in at the end of the query string, basically to, you know, keep track of different things for you.
Probably category.
Category equals 0. Yeah, probably. Yeah, this you're absolutely right, Aaron. This goes with the database of some sort. I'm not sure what it is, because I don't know the internal workings of Walmart.com. When you send over your requests, there's other things that you can include. Now, this is not an exhaustive list by any means, but this is just some of the common things that you'll see. So the host is going to be whatever.com, like google.com, amazon.com. The accepting language is EN. Based on the country, and most of the time you're going to be saying, like, I'm going to send you a request and I expect something back in English. So if you go to any store, most stores in like major cities in the US, if you speak English to the person behind the counter, that's basically saying, when I speak English, I'm expecting English back. That's a nonverbal piece of communication that I have. When I go to other countries or something like that and I speak English, I'm still saying that, like, I expect English back. I might not get English back, but it's like I'm explicit. That's some like unspoken thing. When I speak English, I expect someone to speak English back to me. When I speak in Chinese, that might prompt a different language coming back to me. But that's something that humans understand, but computers don't. Computers, you have to be very, very specific on what am I willing to accept coming back. So EN is the thing for English. There's SP for Spanish. There's a whole bunch of other languages that are that you would expect to come back with. User agent we talked about, and this accept on the bottom here is basically like, what am I interested in receiving back to me? Is it just going to be plain text? Is it going to be HTML text? And is it going to be an image? Is it going to be JSON? This is what I want to get back. On the other hand, so that's all about requests. Again, requests are look a little something like this. They have different methods: the get, post, put, and delete. Get is to get resources. Post is to send something new. Put is to update something that exists, and then delete is to delete anything that exists. We talked about URNs and URLs. We talked about some of the headers, and some of those headers include like the host that we're sending it to, what language we're willing to accept, what type of device is making this request, and what I'm willing to accept coming back to me. The other, so that's the client side. You make a request every single time that you type in google.com, all of this is happening in the background. Anytime you visit any website, this is happening in the background. The other half of the equation is the response. And this is the way that the response is broken up. You start with the status line. It also has headers coming back, a blank line, and then the body that's being returned. So we'll start with the status line. The first thing is the status code. The reason phrase is second, and then the HTTP version. Again, we're still on 1.1, so you can always assume this is going to be 1.1. These numbers in the front here are basically families of codes. Nobody knows all of the codes, but everyone knows the general family of things. So you've seen like error 404, if you visited a website, something happened. That means something blew up on their end. So there are like hundreds of different status codes, but they're all under different families. So anything that starts with the 200 is okay, meaning your request is good. A 300 code, anything that starts with the 3 is something happened and I need to redirect you. 300 is for redirect. 400, anything that starts with the 4 is there's an error. And then 500, there's an internal server error. And the way that I kind of think about it is, let's say you're out at a bar or you're out at a restaurant or something, and you see somebody that you'd like to, ask out on a date. So you ask you walk up to this person, and you are the client. You're making a request to the server, which is this other person. You say, I find you very attractive. I saw you caught my eye. Maybe can I buy you a drink? That's the invitation, right? A 200 response code is, oh yes, I am very interested in you as well. I saw you coming over. I like you. Let's get a drink. I'll allow you to buy me a drink. That's the 200. Everything is good. 300 is, I hear you. Why don't you talk to my friend? I'm redirecting you. Thanks for coming over. Let me introduce you to my friend over here. 400 is just no. I'm not interested in you whatsoever. Just go away. This is not going to happen today. And then 500 error is an internal server. Something's happening with me. It's not you, it's me. You can think of it that way. You can think of I had bad scallops last night. There's something wrong with me. I cannot process this right now. So again, 200, yes, I'd love to go on a date. 300, why don't you talk to my friend? 400 is no, and 500 is bad sushi, or undercooked eggs or something like that.
Got a lot of 400s.
You've got a lot of 400s? All right, that's all right. At least you did not get redirected to the thread. That somehow feels a little bit more defeating. So you want to look for mostly 200 status codes. 300's okay. 400 and 500 are bad. 400 you have to worry about because something happened on your end. 500 you don't really need to worry about because something happened on their end.
So are any of those codes considered security vulnerability?
No. I think those two concepts aren't terribly related. Yeah. So again, you need to know these status codes. You don't need to know every single one, but just the family. Anything that starts with the 200 level series status codes, okay. 300 is redirect, 400 is no good, 500 is internal server error. These are also explained by dogs. So if you look up status codes, dogs, HTTP status dogs, there are so many status codes that there's no possible way that everyone can memorize them. So it's kind of a 200 level is okay. I'm happy. Look at this happy dog. It's a very standard response for a successful request. Then you have 300 levels. I'm going to redirect you. There's multiple choices. I'm not sure what 300 actually means. I know 301 is moved permanently. So it's kind of if you go to google.com, it'll actually 301 you to https www.google.com because google.com doesn't exist. It automatically redirects you. So this move permanently looks like a cat has taken over the big bed and the dog has to fit in this tiny little thing here. There's 400, 404 is not found. That's the one that everyone is used to. So this dog is looking for a bone, but it's not found. And then there's 500. There's so many. Again, you can see there's so many of them. 500 is bad gateway, something is happening internally. So there's HTTP status dogs, there's HTTP status cats, there's a whole bunch of HTTP statuses, like fun little images to kind of help you out. But you just need to memorize the main family, 200, 300, 400, and 500. There's also a status code called I am a teapot, which is really annoying, but it's still there because someone messed with it. There's 418 because it starts with a 4. It's an error code on your end, and it's literally I am a teapot. I'm not sure what the story is behind it. You can read about it at your leisure. So that's a little bit about the status codes themselves. When you get a response back from your server, there's also some headers that are being sent back and forth. Remember, headers are those, like, when we talk as humans, there's nonverbal communication that's happening, smiling, shaking of hands, and things like that. There's unsaid things. Computers don't operate that way. They need to know everything very, very explicitly. Response headers, what am I sending back? I'm sending you back HTML. I'm sending you back CSS. I'm sending you back an image. How long is the thing that's being sent back? Cookies we'll talk about in just a second. So your client also may send back your server may also send back a cookie, and then this is what date was the response actually sent back to you. So these are examples of some headers that you may receive. As you've noticed, when I go to google.com or go to walmart.com, all of these things that are happening under network here, these are all HTTP requests. So if I clear everything out and press enter here, it's not just one thing that's happening. This is the main thing that's happening, but you can see there are, upwards of 42 requests in the background that are happening in order to load up this one page. So just by hitting walmart.com with black Jordans, now there's 87 things going on, and I'm guessing it's going to increase because they like to know things about you. Like, they needed to reach out to beacon.js. It needed to reach out to ads.js. Also, it needed to reach out to get this particular image onto the screen. Like, they had to actually make those different types of requests. So you can see all of these things that are happening in the background. Like, when you hit google.com or walmart.com, these are all the things in the background that are also being hit.
So ads.js refers to a file, kind of like how we have different files.
Exactly, yeah. Something on their end, internally, they have something called ads.js. You can actually just see what's in there, I'm pretty sure. Yeah, so it's ads.js is actually just Google's ads.js preview. So this is all the code that happens behind the scenes for ads.js. Somebody wrote this and then minified it. Minified meaning I removed all the blank spaces, so it saves some room overall. So yeah, all of these things are just happening on the back end. So it's not just one thing that's happening when you make those requests. All right, we're coming up on the end here, but one thing that I want people to know is that the web is stateless. I didn't know this until I read this slide, but the web is stateless, meaning that every single time that you talk between a client and a server, it's as if you're talking for the first time. Think about this classic movie, 50 First Dates with Adam Sandler and Drew Barrymore. This was, I think growing up, this was on like USA like every weekend, so I watched it like all the time on the weekend. But I remember this one is particular. This one represents stateless for me very well because for those of you who aren't familiar with this terrible, terrible movie, Drew Barrymore has anesthesia. No, amnesia. Anesthesia. Drew Barrymore has amnesia, which means that she, forgets things and doesn't have a longer-term memory due to an accident. And Adam Sandler is trying to sees this person, the Drew Barrymore, and like falls in love with her, but like over and over again, she doesn't remember who he is, even though they've talked before. So every single time that Adam Sandler talks with Drew Barrymore and they go on a date, it's as if she's meeting him for the first time. So that's hence the movie 50 First Dates. A web request is very similar in this sense that even though I visit Google probably 50 times a day or something like that, maybe 100 times a day if I'm doing a lot of development. Every single time that I talk with a server, calling in, Mike? Yeah. Is there an issue with sound?
Yeah, click buzzing.
There's buzzing. Okay, we'll find out.
Oh, yeah, there is.
Hold on 1 second. Let me change my microphone. Hopefully this is a little bit better. Oh, it is? Good. All right. So I will figure that out later. So again, so every single time that you send a request and response, it's stateless. It's the first time you've ever talked to Drew Barrymore. You know, like they won't remember who you are. Or even in a more real life example, if you meet a celebrity and you take a picture with them and you talk with them for 5 minutes, the next time you meet with them, it's as if they've never met you before because they meet a lot of people, right? They're not going to remember some layperson on the street. So you can think of that as the relationship between a client and a server. So I send a request over to Chase. It's the first time I've ever talked to Chase, even though I may have talked over and over again. But there's an issue. Like, that makes for a terrible web experience, because if I go to chase.com and I have to enter my credentials every time, and then I also have to authenticate myself using the text message every single time, I'm not using chase.com anymore. So how do we get around that? There's this concept called cookies in when you talk about like HTTP requests. It's basically little crumbs that you leave that are sent back but from the server to basically send along with your request, so that future requests, they know who you are. An example of cookies is kind of like if I were to go on walmart.com here and I add this very expensive shoe to my cart. Gosh, there's a lot of things happening in the background to do this one thing. I go to another instance of walmart.com. Even though they're two different tabs, when I send this request over, I received some cookies in the background. So the server sent me back cookies, and when I make a subsequent request over here, it knows that I've added one thing to my cart, these black Jordans. Don't embarrass yourself. Okay. Right here. And so it's like, even I've added it to my cart. It's my first time I've ever talked to walmart.com. Walmart.com sends me back a cookie so that every single subsequent request, it'll know that like I made this request previously. If I were to open this up in incognito and I went to walmart.com, this particular incognito instance does not share the same cookie. That's why, like, when you visit things using incognito, it doesn't save any of your cookies. So even though I have Google Chrome on two different windows, one is incognito and one is regular, this one doesn't keep track of cookies. So it's the same browser and the same machine making the same request, but this doesn't record any cookies. If I were to go on Firefox and go to walmart.com, that browser does not have that particular cookie. Cookies live on your machine only. So you don't have to worry about like, yeah, they live on your machine.
Where are they stored?
They are stored on your browser. So your browser keeps track of all of that for you. That's why what's that?
Cache file.
It's probably it uses the cache file. That's why your browsers use so much of your operating bandwidth power on your machine. And if you use Firefox, it uses like 100% of your memory because it's just doing so many things in the background in order to send these requests back and forth. So tomorrow we'll talk more about cookies, but here's a summary of it right now. So you're a client, you make a request to the server. The server sends a response back to you with cookies as part of the HTTP response. Your client, your machine, your browser will store those cookies. The server doesn't store anything. And then anything that you send in the future will also include those cookies, basically saying like, I'm already logged in. You know, it's that little button that says keep me logged in for 2 weeks, and you check it. There's a little flag that comes back with it and says like, here's a cookie that, like a token that will expire in 2 weeks, and then you'll have to log in again. That's about it. The HTTP is just a protocol that goes back and forth between you, the client, and the other machine that's a server. Any questions on anything?
So part of the the user experience that is added by some of the caching that
Mhm.
goes on with your browser? Is that
Yes.
something that just basically the browser is responsible for? Can an actual web developer tailor those, what type of metadata is actually cached and things like that on your websites?
So you as a web developer can choose what cookies you're sending back. So like if you're a developer for Amazon.com, right? You are writing code on behalf of the server. The server is going to be Amazon.com. You can choose what cookies you want to write and set with the responses that you send back. In terms of the actual what the browser keeps track of, it just keeps track of cookies, but it doesn't have any control over what is being sent back. That makes sense. It's just in charge of storing things. So, what else is there? Where are my cookies? I know.
So when we're building websites, we have to actually make those. Do we write out those statements then, those request forms?
So those requests and responses are actually, that's a great question. So just to summarize in case people didn't understand, when you write code and you're starting to write web applications, do you actually have to write out all of these ridiculous looking things? No, that's the good part. So this is what's happening underneath the hood. So I have something called a GUI interface, graphical user interface right here. It's something I can see, something I can click around with, something I can touch on a phone, and I make a request to google.com. Google.com, underneath the hood of what's happening here, if you go to right click, go to element, go to network, and so let's clear everything out and refresh. Google.com, I'll click this right here. So you can kind of see what's happening. This is what's happening underneath the hood. Most of this will match up with what we've been taught today. Like this is all the things that are happening underneath the hood. Some of these things may make sense to you now. The request URL is this. I have a method called get. I got a response code of 200. This is the date that it was sent over. There are some cookies that were set back from the server. So it says that, I don't know what SIDCC is or any of this, but this is stuff that was sent back from the server. Some of the request headers that I sent over, the path was just /. I was using HTTPS. It was a GET request being sent back and forth. This is stuff that Google Chrome and your browsers kind of wrap around for you so that you don't have to type in these things yourself. But in the end, like it is still being done. It's just something is making it nicer. You're going to be using something called curl today, which stands for command URL. If I just curl HTTPS, when I curl google.com, I make a GET request to google.com. This is what I get back. This is everything that happens inside the body. If I grab this code, open up Sublime, create something new called delete.html. I paste this in here, and then I open it in the browser. The response that I get back looks very, very similar to google.com. Obviously, I'm not making actual requests going out to Google to get these images and things like that. But when I make a request to Google using curl, which is a similar thing to which is a non-GUI interface for your command line, like this is the response I get back. This response, when I get it back on the browser, like the browser knows to translate all of the HTML code to actually just look like this. I think I just lost every single person. All right,
No,
so
it's CSS, right?
what's that? Yeah, it's HTML. It's just HTML and CSS. Some JavaScript in the background. They may have made a request to get this particular logo or my particular face in the right-hand corner, but underneath the hood is this. Like everything that's just being sent back and forth is just text. Like I'm just sending back and forth text. Your browser, your Google Chromes and your Firefoxes will read that huge block of. This doesn't make sense to anybody. but your browser knows how to read it and then translate it into making it look like what you're used to, that google.com.
So I'm sure there's other commands for curl.
There is. You're going to spend a lot of time with that today if you decide to work on it. Are there any other questions before I go into today's work? Okay, let me stop recording here.